Well, thank you, Tish. I mean, this is my first time here, and this is just an amazing event. I'm really glad that I live in the Bay Area now so I can come down to things like this. Now, back when Tish and I met, I was at O'Reilly, but now I work for PCH International and try to help startups come over to China and go big. But this isn't my first foray into hardware. I go to this thing kind of like Second Life. It's called Burning Man. And in 2004, some friends of mine and I made a car. And this is, 24 seconds of some of the 3 hours that it actually moved. It was a rotational car. It could spin in place, as you'll see in the next video. And it could also move forward. And it could spin while driving. And then we had theories that we would take it out to deep desert and put on some Barry White, and it would rotate slowly. We never really got a chance to play around with that part. But it was 3 wheels, 6 motors, 3 for drive, 3 for steering. We had visions of using Xbox controllers to steer it, but our EE was colorblind. So we ended up using like a little control panel instead and spending 48 hours coding on Playa. But this was a real project. We had a Mech-E, we had 2 PhDs. This was before Arduino, so we had our own motor controller. And of course, we had lighting. This is my favorite picture. Eventually, we realized just the VC funding climate wasn't right just then. Tesla had sucked all the juice out of the air. So with this novel idea of building cars that would actually fit on a road. So we decided not to take it out for funding, and it ended up as a couch in a bar. It was our bar. It was a speakeasy, so it worked out well. But I'm here to talk about hardware, because augmented reality is ultimately dependent on the hardware that you're wearing. And eventually, maybe that'll be wetware. But right now, it's things that you fix to your glasses. It's your phone. And it's all about interacting and connecting the virtual world to the real world without a browser and doing some sort of overlay. Now, we are all here to do this because hardware is fun and because we want to change our reality. But of course, there are a lot of companies that actually make a lot of money doing hardware, and so there's a bit of a hardware renaissance going on right now. And you see that with wearables like Pebble, or with Ouya, a $99 game console that's going after Xbox. And of course, with Microsoft's latest steps, that'll be a lot easier, but it was still a pretty bold vision when they tried it last year. And what entrepreneurs today have that I didn't have back when I had grand visions of moving hot tubs is a pretty solid stack. For software, you've got Upverter. You've got GitHub for sharing those files. For development, you can practice on an Arduino or a full-powered computer, Raspberry Pi. For marketing, you've got Kickstarter and Indiegogo. And for retail and fulfillment, you've got Amazon, which will take your product and ship it around the world for you. And your IDE is your tech shop. It is your makerspace. But what's really missing is AWS for hardware. And by that I mean the thing that allows startups to scale without spending a lot of money on factories or for software services on servers. Now, around the world, there is a place that is a lot like what I imagine Amazon's data centers are like. It's probably a lot messier. Meet Shenzhen. Shenzhen is in the Guangdong province over in China, and there are thousands of factories over there. And in the heart of Shenzhen is Huajianbei. I don't know if you can see the outline there, but it's about 16 square blocks, where if you need one type of resistor, you can go find the people who made that resistor and then talk to the booth next to him and find out how much his competitor is selling their resistors for. And you can do this for LCD screens. You can do this for Android TVs that are more powerful than Raspberry Pis, and yet half the cost. You can do this for, I'm sure, fully licensed Angry Bird phones, for about $15 for Miss Kitty or whatever she's called phones. And then for a $12 phone. This is a $12 phone bought over the counter. And if you take it apart, it's put together with glue, 8 buttons, and a single board. And it'll work on China's networks. So I mean, hardware costs are plummeting, and what there needs to be is a way to actually scale up and iterate through. And China, I think, right now anyway, is the key to that. And Apple, of course, sees this, or some variation on that. And when you're over there, you can actually get real Starbucks. But what I think the sexy thing for all of us is if you go over there, you get a real peek into how the sausage is made. And you can go on tours and see how these things that we carry around in our pockets are actually built. I'm going to have to hop out of PowerPoint to show you this other video. But that's a pick-and-place machine. There aren't too many of them in the US. Adafruit, actually, has a $200,000 Samsung pick-and-place machine used to build cell phones in their Soho factory. But it's the rare US company that's spending money on that right now. But Shenzhen isn't just about the factories. There's also makers there, and there are entrepreneurs who are building things, taking advantage of what's going on in Huajianbei and in that ecosystem. And you can learn a lot from just being there. They're very open with sharing about how they made stuff and about where you can get parts. And it's a place where they don't just worry about factories. There's also fashion. Now, as I mentioned, I work for PCH. PCH is Pacific Coast Highway. And some of you may recall the Chumby. Yes? No? Well, PCH actually made the Chumby with the help of this guy, Bunny Wong, who hacked the Xbox years ago. And what PCH was for Chumby was basically their AWS. Chumby just had their business folks and their developers, and then they would send Bunny over to China every so often to work on the manufacturing and to figure out how to actually make this computer stuffed in a pillow. And so PCH handled manufacturing, distribution, the packaging, the sourcing, and they pioneered direct C2C shipping, Chumby to customer. Now, I normally don't like to do pitches, but this is I actually think PCH is unique enough that most people aren't aware that this is a possibility for them, that they don't actually need to hire people in the floors. They can actually go to the equivalent of an AWS. And PCH, just for the record, is a fairly large company with about 10 million SKUs flowing through it daily, most of Apple's accessories, and $8 billion in product worldwide, working with thousands of factories that we don't own, but instead supply the engineering for. Now, I joined to work with startups, and we have 7 companies that we work with, where we're letting them be lean like Chumby was, and we are their back end. They're focused on what the product is, but instead of having to spend their nights and weekends and months over in China and potentially having major issues, they rely on us. And 4 of these companies are shipping now. Lively is going to be shipping in about 2 months. And hardware, much like software, has a definite set of stages. There's the design stage, where you figure out what it looks like and how it's going to work. The develop stage, where you start to make more advanced prototypes, and you start to work on the dyeing and tooling. The pilot, where you actually do some initial runs and then finally, when you start shipping to your customers. I'd like to dive into Lively right now and talk about how we've worked with them and what they are. Lively is a Bay Area startup that places sensors around your aging parents' homes. They're currently piloting in Florida, and the idea is that you would know if your parents didn't open the refrigerator that day or didn't go to the medicine cabinet. And so you place these little sensors on the fridge door, and then you get a dashboard. Now, Lively is about to ship, and they've only spent 1 week in China so far. Everything else was handled virtually. They didn't have to hire a supply chain VP or an operations manager until late in the process. And as part of the accelerator, we supply them engineering for equity, any PCH service, and a dedicated engineering team. And what we seek is basically a great team building something awesome. Now, what I came on to do is actually something really new, which is to launch an incubator. And this is devoted to helping people learn about manufacturing and those kind of dark arts that happen over there. Because what we learned was, it's not just that startups only have small volumes that is a barrier to entry to larger factories and lower prices, but actually just kind of a lack of knowledge about how the process works and lead time for components and how to handle inventory. Things that you kind of forget about when you're on the web, and you can just scale up another Amazon server. But when the world is about to run out of LEDs and you didn't order them, suddenly your product can't ship. So the goal of the incubator is to create a world-class classroom around manufacturing, around retail, to basically create an ecosystem where hardware startups are just as easy to do as software startups. And hopefully, 1,000 augmented flowers will bloom and the glass is created. The incubator is going to focus on this curriculum. It'll be 4 months long. It will be in San Francisco, with 2 weeks in Shenzhen, roaming around the factories, learning how to actually build the prototypes that you've painstakingly built in the US, but how to actually go to market with them, how to build them with the components you'd be using and within the factories that would be processing them. And it'll all be in Dogpatch, in our new building in the Bay Guardian building. The second floor is going to be a tech shop, and the third floor is where the incubator desks will be, packed with equipment like Other Mill, which is going to be made in San Francisco. The building right now is under construction, but it'll launch in time for the first class. Now, the difference between these two is in the incubator case, we're just trying to teach you how to do manufacturing. There's a lot of in-kind engineering to work on the product so that you could go anywhere and go get it made at the end of this program. And in the accelerator case, it's more of a business relationship where we are actually making your product for you. Now, to get you started, I recommend that you just kind of surf Alibaba if you want to make hardware and see what's out there and what's available. I recommend that you read Phil Baker's From Concept to Consumer. He worked at Kodak and has launched a number of hardware products. And finally, I recommend that you read Bunny's blog, which is just spectacular. And you can read the teardown of the $12 phone, and you can read about his quest to build a laptop on his own. Thank you.
Thank you, Brady. Any questions? I have a question, but I'm going to wait and see if there's anyone who's got a question from the audience first. Yes.
I come from the hardware background, so I've spent 11 years in tablet computing.
Mm-hmm.
We've been on the path of making our own tablets. So we've
Thanks.
Shenzhen was interesting to work with. Are you exploring also other avenues like South Korea as well?
Right now we're not, but I can't comment directly for PCH, but I think as prices rise, you could see other geographies being used. But realistically, the ecosystem that is there in Shenzhen is not something that can be replicated elsewhere. Even if you are doing, if you were, say, had factories in Tijuana, you're getting your components from Shenzhen. So you have to really think about, do you want to be near your components and your suppliers, or do you want to ship them to your custom factory? I mean, MakerBot just opened a 50,000 square foot facility in Brooklyn for assembly, but a lot of their components are coming from China. Someone else? Yep. So the question was, how do you protect the manufacturing? Well, we have 1,100 factories in our database, some with just GPS coordinates. And honestly, my understanding is some of them are ranked on good for secrecy, not good for secrecy. And then also, if you are outsourcing, it's possible that it would get lost. And so there are ways to protect your software. And also, there just will be fast followers. And I think that can happen in any geography. Yes, Tish?
Oh, yes. So is Nick Pinkston in the house? Maybe not. I was talking with Nick about the manufacturing challenges for eyewear. And we are actually, this is the first year I think we've had really a lot of prototypes of eyewear coming from small startup groups. Do you think, you know a few of them perhaps, is that realistically something you could take on in this incubator program at this point, or would you, like Nick said to me, he's going to be looking at that in maybe a year or so?
We would certainly take them on the incubator. We'd have to see if it made sense for us to actually make the product.
Right.
But
right.
That's
so
a mixture
that's the difference between the incubator and the accelerator.
The incubator, it is really about teaching.
Right.
And trying to inform and help people understand. We'll be putting up, we're going to have a lot of speakers come in, and most of those talks, with their permission, will be online, along with their notes.